Hello and welcome to Maths with Jacob. This lesson will focus on Tricky Maths Part 45. If the diameter of each circle is 2 centimetres, what are the measurements of the red square? So here's your chance to pause the video. If you would like to attempt this yourself, you can pause the video now. I will now move on to the next slide to discuss the solution. If each circle has a diameter of 2 centimetres, then the sides of the large square must be 4 centimetres. So we have 2 as one diameter and 2 for this diameter. That gives us 4, and it's the same here. So, using Pythagoras' theorem, we can find the length of the green diagonal D. So this D represents the length of the green diagonal. So applying Pythagoras' theorem, where the square on the hypotenuse equals the sum of the squares on the other two sides, d squared equals 4 squared plus 4 squared. D squared is 16 plus 16, which is 32. So D is the square root of 32. And if we simplify that, we get 4 the square root of 2. So that's the value of D. So the green line is 4 the square root of 2. So remember, D equals 4 the square root of 2. Now, here we have something very interesting to note. Each of the 4 small lines with the black dots are equal. In other words, from there to there, that's one of the small lines. From here to there, from here to there, and from here to there, they are all equal in length. And you can prove that just by looking at this section here. You can see straight away that that part is equal to that part. And if that part is equal to that part, that must also be equal to this part. So those 4 short lines are equal. Now, we're going to pretend that each of those 4 lengths here, so there's one of them. See that one there? That's one of them. We're going to pretend that is m units long. Okay, so m is the length of that small section. So that's also m, and that's m. So 4m, which is this plus this plus this plus this, plus 2 plus 2. Plus 2 represents that diameter, plus another 2 represents that diameter. So this gives us the full length of the diagonal. That must be equal to 4 the square root of 2. Okay, 4 the square root of 2. So 4m plus 4 equals 4 the square root of 2. Now, 4m, so if we subtract 4 from both sides, 4m equals 4 the square root of 2 minus 4. So we'll continue this on the next slide. So from the previous slide, 4m equals 4 the square root of 2 minus 4. Now, m, if you divide both sides by 4, m must be the square root of 2 minus 1. Okay, so in other words, this little dot here represents m, which is the square root of 2 minus 1. This is half the length of the red square, because from here to there is just half the length of the square. And when we add this section, that is the full length of that red square. So the full length will be, you take that part there and you multiply it by 2. So that gives us 2 the square root of 2 minus 2, and the answer is in centimetres. So how's that for a very, very interesting sum? It required a bit of thought, didn't it? I wonder how you went with it.